Welcome back to our series on applied regression analysis. I'm Mark Ledbetter. This is lecture video 18. We're still talking about straight line regression. This is part 6. We only have one more part to go in this chapter. So, last time we talked about predicting, or this time we're going to talk about predicting a new value of y at x naught. Last time we talked about predicting the mean value of y at x naught. So last time we came up with a variance of s sub y given x squared times 1 over n plus x minus x bar squared, that might be an x naught, over n minus 1 s sub x squared. Okay? And that is the variance that we're going to use in the, we're going to take the square root of that, and we'll use this for predicting or calculating a confidence interval for the mean mu sub y given x naught. So we use that. Today we're going to talk about just predicting y, and we're going to end up with s y x squared, and we're going to have this extra term 1 plus 1 over n plus xo minus x bar squared over n minus 1 sx squared. Okay? And then, of course, we take the square root of all that. So if you look, if we distribute that, actually do it like the one above, we can put that in parentheses, we end up with this expression here, and then we end up with this extra term of the variance here. So this definitely means that we're going to have higher variability for an individual point than we would for the mean, and that makes sense, right? So what are we talking about doing here? We may want to estimate the response of y, a single value, based on the regression line. Another way to say it is we may want to predict an individual's value of y given x naught, not the mean value, but the individual's. And the point estimate is still going to be y hat, because it's still the best estimate that we've created based on the regression line. But instead of just using that value alone, we want to have some bounds, a band around this value to be able to see the variability. This is not a confidence interval. Y is a random variable. It's not a parameter like mu. Mu is a parameter based on many points. Y is an individual value. This is not a confidence interval. We're going to call it a prediction interval, PI. Okay? And here is the prediction interval written out in long term. Okay? So you now have the formula. I don't believe the book explicitly gives that to you, except maybe in a table somewhere. The key points are the variability of a single point should be larger than the variability of a mean, the group's mean response. And again, note the extra 1, which adds a whole term of this to it. When predicting an individual's response y, there are two sources of the individual of the error. The individual error measured by sigma squared, and the error in estimating mu using y hat. Okay? So we can decompose this difference of y to y hat into two parts. We can subtract and add this mean, and now this part is the deviation of the individual from the true mean at x naught, and this is the deviation of the y hat value from the true mean. And so when we take the variance of this, we also take the variance of this. And it turns out that these two are independent of each other. And so we can just write them like this. Well, what happened to the mu's? Well, if you remember from last semester, those of you who've taken 333, if I take the variance of something minus a constant, the constant gets canceled out, and we're left with variance of y, because the variance of a constant is 0. There is no variation around a constant. And so that's what happened here, and the same thing happens here, and we end up with this variance with sigma squared. Of course, we replace sigma squared with this, its estimate, s sub y given x squared, and that gives us the estimated variance that we saw up above. So these are called prediction bands. I made a mistake there. And they're used to describe individual predictions over the entire range of x values. So a prediction band is not just for one value of y, we do it for every value of y in the data. And I've, to shorten the notation a little bit, I've given this a notation S sub y pred given x naught, and that is equal to this portion, and then we can rewrite our prediction band or prediction interval in shorter notation. Okay, all right. So now let's take a look at, this is figure 510 from the book, and it shows the difference between a confidence band and a prediction band. The prediction band is much wider. So you see this one says prediction, this says prediction, that's the solid line here, and here are the confidence bands. And this was for our example from the book that we worked with last time, Systolic Blood Pressure and Age. Notice how we have a straight line, a fairly straight line out here for the prediction band, and we have curved lines for the confidence bands. Okay? And these are 90%, both of these are 90%, not 95% in this case. All right, so I hope that helps you understand the difference between a confidence band and a prediction band. A confidence band for the mean, prediction band for individuals. And that is the end of this video. Please don't forget to scan your lecture notes by midnight of the date listed on the course calendar. Be neat for you. Update your formula sheet for the test using the formula that I gave you today, whichever version you like better. And we will see you. Oh, before I say that, as always, if you have questions, please come to my virtual office hours. If you can't, email me. If you email me the problem, because I may not be near the book, and email me your work. Both of these are needed, and then I can help you the best. So, take care of yourself. We'll see you next time.